Yeah, first step is put it in standard form. Is it in standard form? So you have to put it in standard form. So yes, you have to FOIL to do that. So if you actually do this out, you end up with 2x squared minus 6x plus x minus 3 is equal to 6x. Is it in standard form yet? No, because it all needs to be on one side. So what do you get? 2x squared minus 12. Oh, wait, minus how many x on the left?
Minus 11x.
Yeah, well, not 11. It's minus. You're right. Oh, and I did it wrong right there. It's not minus 7. What is it? It's minus 5x minus 3. I'm just doing it. I'm doing it in a lot of steps. Okay. So what do you end up with? 2x squared minus 11x minus 6 equals 0.
Yes.
Is this standard form? Yeah. Standard form is ax squared plus bx plus c is equal to 0. Yes, for standard form for a quadratic. Yes. So now what are we doing? What's the next step? Factor. So if we factor this, this isn't 1, but is 2 the next best thing? Yeah, it is. So if we actually do this one out, we know it's going to be 2x and what? X equals 0. And we want two things that multiply together to get negative 6. But we have to build a relatively big number because negative 11 is a little bigger than 2. So we want to make sure maybe it's going to be minus 6 and what? Plus 1. We're not automatically sure if that's correct, so what should we do? We should check it, right? So if we check this, it ends up being 2x squared minus 12x plus x minus 6 equals 0. Is that what we want? It is. I'm writing pi instead of a smiley face. I don't know why. It is a smiley face like that. Okay. It is. It is negative 11 because we have these two together. Yeah. So now, yeah, go ahead, Obs.
So the first step of every problem
put in standard form
is, and then the okay. And then the product should look like that.
Yeah, it should. It might be a little more complicated if you pull something
like the parentheses.
Generally speaking, you might have pulled out like a 7 first. Like when you look at something to factor, you always look at this and say, is there anything I can just pull out of all three terms? Is there anything you can pull out of 2, 11, and 6? No. So you don't factor anything out.
You just go to the
straight to factor. Yep. So now what do we know? We know that 2x plus 1 equals 0. Or x minus 6 equals 0. So 2x is equal to, so negative a half, or x is equal to what? 6. So the way I want you to write this in order, negative 1/2 comma 6 with the brackets. There's your answer set right there. Yep. There you go. Right. So you have to clean it up first. So let's just do it right. So 2x squared plus 10x plus x plus 5 equals x squared plus 3x plus 11x plus 33. Now you have to make sure it's in standard form. So you take care of these two. What did this become on the left? It becomes x squared, and you have 11x and how many x over here? 14. So it's going to be 11 minus 14 is minus 3x, right? Because it's 11x minus 14x. What's 11x minus 14x? Negative 3. And then you have 5 minus 33, which is negative what? 28 equals 0. Now, what's nice about this one? The leading coefficient is 1. That's nice about this. So now we're looking for two numbers that multiply together to get negative 28, but add together to get negative 3. What do you get?
7 and 4.
Not 7 and 4. Close.
Negative 7.
X minus 7 and x what? Plus 4. Correct. Because negative 7 times 4 is negative 28. Negative 7 plus 4 is negative 3. Does that match what we want?
Yes.
So therefore we know x minus 7 equals 0, or what? X plus 4 equals 0. So x equals 7 or x equals... So when you're not done, you write it as negative 4 comma 7 with those brackets like that. This means a set right there. The set of those two numbers. Those two numbers right there. All of these. Standard form. Put it in standard form. So it's going. You take these two. What does it become on the left? Just x squared. And then you have negative 4x plus 3x. So what does it become on the left? Minus x. Because you're adding 3x to both sides. And then you have minus 12 equals 0. What's nice about that one? The leading coefficient. Guys, say that out loud when I ask. What's nice about that one? Leading coefficient is 1. If the leading coefficient is 0, the x squared goes away. What is the coefficient right there? 1. It's invisible. It's 1. So what does this factor into, Summer? minus an x plus something. Nope. It adds together to get -1, but multiplies together to get -12. X minus 4 and x plus? Yeah, so x is equal to 4, or x is equal to -3. So what's the answer? -3, comma 4. Make sure you put it in the set note. So it was 2x squared plus 5x equals 3 minus 2x minus 4x squared. What's the first thing you have to do? So if you do this, you end up with 2x plus 4x. You end up with 6x squared. 2x plus 5x plus 2x is, and then you subtract 3, and you end up with 0. So the first part was put it into standard form. Is it in standard form now?
Wait, wasn't it 2x squared minus 5x?
Nope, 2x squared plus 5x. It was.
What? Wait.
I just literally copied down the question from the quiz right here.
I know, but I'm just.
This is it right here. I'll get rid of the circle so you can see it. That's it. So what happened? The 2x and the minus 4x, we added 4x and it became 6x. And then I took 5x and -2, so what does it become? And then I subtract.
That's why.
Ah, did that clean up your problem?
Yeah.
Yeah, okay. So then what is the next step? Next it's factoring, yes. Next it's factoring.
I think it was
Factor this? Well, how about this? You can work on it. What does this mean? You have something divided by 3. Each individual thing is being divided by 3. So if you were going to simplify this, can someone tell me how you would go about simplifying this? What would you do, Connor?
it'd be 5x squared
Ah, so why'd you get 5?
because 15x.
So it's 15x squared over 3 minus 12x over 3 plus 6 over. You break it into 3 separate fractions, and what does this simplify to?
5x squared
Minus
4x
plus.
2.
So this one's nice. This is as nice as it gets. You have a single constant, and you are dividing by a single constant. That's as nice as it gets. Can it get a little bit more complicated?
Sure.
You can get a little bit more, so let's ramp it up a little bit. So instead of a single constant, we have a single term, but it's not a constant. But does the methodology change? No, the methodology doesn't change. You break this apart into how many fractions? 3. 5m cubed over what? 5m squared minus 9m squared over 5m squared plus 10m over. Can you simplify these individually? Yeah, what does the first one become, Aubrey? What does the first one become? M. That's correct. Just m. That's correct. The 5's cancel. M cubed over m squared is m. Harry, what does the next one become? What does this one become right there? No, these cancel, leaving you with what? Correct. And then what does the next one become? Alex, what's the next one become?
2
Over. Nope, just 2 over m. Because this goes away, cancels that, and you're left with what's 10 over 5? 2. There it is. Why did it get that? Kids, this one right here, if it's confusing to you, I'll do it out separately. If you are confused as to why that one did what it did, let's take a look. What does it become? This is 10 times m over 5 times m, right?
It's just 1 over m, right?
So what does that become? That's 2 times 5 times m over 5 times m times m. What cancels? A lot cancels, right? The 5 and 5, the m and the m, what's it leave you with? 2 over m. Yes. There it is. That's it right there. So did we simplify that? Yes. But again, what's the common thing between these two examples that we just did? You have one thing and what? One thing. There's a single term in the denominator and there's a single term. Single term. There's a single term in each. Yes, Nick? Could you break this apart into 3 fractions? Yeah, sure. It'd be 2m squared over what? m minus 2 plus m over what? m minus 2 minus 10 over. The problem is there anything you can simplify there? There ain't. There ain't.
No, you can.
What can you do, Hannah?
The numerator, you fix it so you can actually take m from 2 or something.
Not really. These are all subtraction, right? These are all subtraction, correct?
I'm talking about the first one.
Yeah, we haven't. Hold on a sec. Hold on a sec. I'm saying, look at this right now. Those.
Those are gross.
Yes, I understand that. My question is, can you simplify those individually? No, you cannot. There's nothing to cancel, right? You know that what's a over a times b? What can you simplify that to?
B.
Just 1 over b, correct? Do you agree with this right here?
Yeah.
Okay, what about this? A over a plus b. Can you do anything to that? No, you can't cancel. Do you know how many times I see this and people are like, oh, this is equal to 1 over b. Is that correct? That makes me sad. I actually cry a little bit on the inside every time I see that. You can't do that. No. So going back to these are all mathematically correct right here, but can you do anything to this? No, you can't. Okay, so if we can't go any further, and I said I would like you to simplify this, let's say you weren't looking at this, instead you looked at this. When you look at this, what do you see? The thing I just circled a bunch of times. Something you may want to what? May want to what? What? May want to factor.
No.
Maybe. Maybe you could factor the top one, right? But we haven't done factoring if we're doing this in order, right? So maybe, though, that's a great thing to keep in the back of your mind. Maybe you could factor, and what do you hope is a factor of this thing? n-2. Because if n-2 is a factor, what can you cancel? You can just cancel the n-2, but we're not going to do that. Instead, I'm going to ask you a related question. Here's something you may remember how to do, or may shudder, I don't know. What happens if I asked you to do this? 1,680 divided by 13. How do you do that if I didn't give you a calculator? Long division. So what would you do? 13 divided into what? 6, 8, right? How do you do long division? Well, I'm going to teach you. So listen and stop talking. Here we go. You look at your 13 and you ask yourself, can it go into, does 13 go into 12? No. So you have to look at it going into 126. How many times does 13 go into 126 without going over? Yeah, you do. What's 13 times 10? Is 130 bigger or less than 126? So it's not going to be 10. What is it going to be? 9. So we put a 9 right there. Once you do the 9, what do you do with 9? You multiply by 13, and that's 90 plus 27. What's 90 plus 27? 117. And then what do? Subtract. What's 126 minus 117? 9. Bring down the 8. Now you go 13 into 98. 5. Let's see, 50 times, that's 50, 65. What about 6? That's 60 plus 18. 78. What about 7? I think it's 7. So what do you do with once you have the 7? You multiply the 7 times 13, and that's 70 plus 21. What's 70 plus 21? 90. Oh, that's good. So you subtract, and what do you get? Can you go any further? No. So what is that 7 called? This is important, this is called the remainder. So what did we just figure out? We just figured out that 1,268 divided by 13 is equal to what? Plus 7 over 13.
Or 97 and 713.
Correct. I like the plus because I hate mixed fractions. Hate them. Hate them, hate them, hate them. They are terrible, evil, and only hurt you later in life. 97 plus 7 over 13. Okay, so we just did long division, right? This is called what? Long division.
Was it like third grade math too?
Well, yeah, but here's the thing. Do you know what you used to learn in third grade too before you had a calculator? There's a similar thing that looks just like this for square roots.
They just gave me a calculator.
Stop. Shh. There's a similar thing just like this for square roots. Do you learn how to do square roots by hand anymore?
No.
If I asked you for the square root of 7, what would you have to use? A calculator. I will tell you, when you were in third grade like 40 years ago, when they taught you long division, they also taught you how to do square roots by hand. It looks just like this, and you can go as accurate as you want. It's really cool. But do you need to learn it anymore? No, you don't. It's actually not that hard. It's kind of cool. So here's the thing. This is long division. Let's go back on what we were looking at right here. What were we doing with this? Are we doing division? We are doing division. We are doing division. But instead of regular long division, what type of long division are we learning now? Anybody want to guess what it's called? Something long division. What's it called? It's called polynomial long division. This is super helpful in this class and in many more math classes. So we're dividing by n-2. So where's that going to go? Right here. And then what's going to go underneath that sign right there?
The 2 squared plus m-.
Yes. So this is the setup here. Here's the setup. You use a very similar process It's very similar. There's only one thing you need to remember. It's a simple phrase. You ready? Leading over leading. What's the leading term here? What's the leading term? What's the first term? What's the whole term? 2m squared is the leading term right there. Do you agree with that? Hopefully. So you have 2m squared. What's the leading term here? M. So you do this division. What's 2m squared divided by m? It is 2m. So after you do that leading division, you put the 2, this is 2m, you put it up here. Just like long division, what do you do in long division once you put a number on top of the division sign? What do you do with this number? What did we do with the 9? We multiplied, right? So you take 2m and you multiply it by this thing. What's 2m times m? 2m squared. What's 2m times negative 2? Negative 4m. What did you do in long division once you had that? Subtract. You subtract the whole thing, remember. What's 2m squared minus 2m squared? 0. So this goes away, which is what we want. What's m minus negative 4m? None of you said the right answer. 5m.
Wait, where did you?
What is...
Oh.
Kids, I'm going to break this down into really small pieces. Please follow the small pieces. What is m minus negative 4m? 5m. What's 2m squared minus 2m squared? 0. Okay, so after we had this number, what did we do next? You told me. You were the one that said, what do we do next after we did the subtraction? What do we bring down this time?
The negative 10.
The negative 10. It's the same process. Okay, now we're back to the phrase. What's the phrase you have to remember, everybody? Leading over leading. What's the new leading term right here? 5m. Whoa, this leading term stays the same. What is it? What's the leading term right there? Just m. What's 5m over m? 5. The m's cancel. M's cancel. What do you do with that 5? Where do you put it? You put it on top. So it's plus what? What do you do when you place that 5? Multiply. What's 5 times m, Nick? What's 5 times negative 2? Minus 10. What happens when you subtract this? What do you get? What does that number represent? That's the what? Remainder. Is a 0 remainder really good? Yeah, so what did we just learn? We just learned, everybody, we just learned that 2m squared plus m minus 10 over m minus 2, what does that equal? 2m plus 5. How do you check to see if something like this is true? How do you check to see if that's correct? You multiply both sides by what? M minus 2. So we just think now that 2m, oh, what did we just effectively do? What does that look like? Oh, we just did a kind of another way to factor. So if you wanted to test this, when you multiply this out, what should it equal? This. You have the divisor. Divisor, right? No, the divisor, right? Dividend. I always get these wrong. Right? I always get it wrong. You have to look it up. Help me with that tomorrow, okay? Anyway, the point is, when you get a remainder of 0, is that a good thing? Yeah, that makes you happy. That makes you happy. So the cool thing is, did we need factoring to do this one? No, we just did division. We just did division. What's missing from this? There's something missing. There's a blank. It skips over something. What does it skip over in there? Anybody want to guess? Well, keep that in mind. Think about what's missing as we do this one. What's the phrase, everybody? Leading over leading. So what's the leading term? What's the leading term in here? What's the leading term? 3x cubed.
Which way do you want it to be answered? Do you want it to be in the form of...
Let's do this, and then we'll get the answer, and it'll answer that question, okay? Kids, this is important. We don't have much time here. Leading, what's the leading term? 3x cubed. What's the leading term here, Aubrey?
X.
X. So it's 3x cubed over x. What is 3x cubed over x, Aubrey? What is 3x cubed over x, Aubrey? What is it?
3, yeah.
3x to the...
Second.
Yes. Once you get that thing up there, what do you do now?
Multiply it by x and -3.
You multiply it times this, and you end up with 3x cubed minus what? 9 what?
X cubed
9x what?
squared.
Squared. So again, I'll ask you, what's missing from the first one? So what you do is you plug 0x squared. Have I added anything if I plug a 0x squared right there? The reason I do that is, what do you do next? Once you get this, what's that thing you have to do now? You have to subtract, right? You're subtracting. Can you add 0 to anything you want? Sure. The reason you add it there is because it makes it easier to see the subtraction. What's 3x cubed minus 3x cubed?
0.
You need it to be 0. That's what you want. What is 0x cubed x squared minus negative 9x squared? 9x squared. What do you think by far the most common error is on these, based on the vehemence of what I just said? Not subtracting negatives properly. You subtract this whole thing right here. Do you have any idea how many times I've seen people subtract wrong? What happens when you subtract wrong on these? What happens when you flip the positive to negative on one of those factoring problems? It does. What do you bring down now, Alex? Yeah, what's the new leading? 9x squared. What's the other leading term that stayed the same? What's 9x squared divided by x? Yeah, and you plug that up here. And now you, what's that one word? What do? You multiply. What's 9x times x? What's 9x times x? 9x squared. What's 9x times negative 3? Negative 27x. Oh, we subtract this whole thing. 9x squared minus 9x squared is what? 0. What is negative 2x minus negative 27x? No. 25x. You have to add. It's a negative. You have to be really careful, kids. Really, really careful.
Wait.
Yes?
Isn't it a -2 minus a -27?
Correct. So negative 2 plus 27 is 25. Please put your calculator away. Please. What do you drop down now? 5. What's the new leading term? 25x. And what's the other one that stayed the same? Over x. What's that equal?
25.
Where do you bring that? Plus what? 25. Now what's that? What do you do with that 25? You? Now it's doing the eraser thing. So you multiply. So you end up with 25x minus what? Yeah, and this eraser is being really annoying now. That's really helpful. Thank you, eraser. So you end up with 25 what? Minus, you said it, Nick, minus what? Yeah, now what's that thing you have to do? You have to subtract 25x minus 25x. What is that? 0. What's 5 minus negative 75? That's 80. Now, can you go any further? No. What's the degree of the x term in this right here? Do you see any x's right here? So the degree is 0. The degree here is 0. What's the degree here? 1. You stop when the degree here is less than the degree here. You stop. So what is this called? That right there is the remainder. So did this divide cleanly? No. You don't add it to 25. No, you cannot add it to the 25. What we now say, Nick, we now said this. This is what we've proven. This is really important. We just did this. 3x squared plus 9x plus 25 over what? What was it? X minus 3. We just said now that that equals what? That equals, can you see that at all? Yeah. What does that equal? It equals 3x squared plus 9x plus what? Plus 25. But what's the remainder? 80 over what? X minus 3, because that's what we're dividing by. This right here would be the final answer. It did not divide nicely. It did not divide nicely. Is it always going to? Yeah, so I would say, if I asked you this divided by this is what you would write down as your answer. You would say this plus 80 over, it's not just plus 80, it's 80 over, remember how we did it was like 9, and the first one we did, 13 into 1,268. It was like 90 something plus the fraction, the remainder. You have to put it over this. This is an important thing to know. It seems nasty. Set this up. The first thing is the setup. You have x plus 3 into 2x squared. Are there any zeros you need to put in there? No, because they're all there. So you have 2x squared divided by x. What is that? 2x. So you have 2x squared plus what? 6x. You subtract, you end up with negative x. What's negative x divided by x? Negative 1. What do you drop down? The negative 3. But you multiply this negative 1, right? So you end up with negative x minus 3. When you subtract it, what do you get? 0. So what does this tell you? It tells you that 2x squared plus 5x minus 3 over x plus 3, what does that equal? 2x minus 1. And you are done. That's weird. It is kind of nice when it does work, right? Can someone just tell me what it comes out to be? Plus 6. It's nice. Now keep in mind, is it always going to be nice like this? No. Sometimes you will have a nasty remainder. Sometimes you will. Keep in mind, you're going to get weird ones tonight on this homework. It's going to seem strange. But what's that one phrase you have to remember? Just do leading over leading. You'll be fine. It doesn't matter what they throw at you. And remember, this was the key thing. 2 key things. 1, what happens when you have a blank? You put that 0 thing in there, right? Where was it? You put that 0. Did I put one in there? Yeah, there it is. See that 0? And then also, it doesn't matter what they throw at you. Leading over leading. Subtracting a negative means what? Adding. Subtracting a negative means? Hey.